Hi everyone. Today we will be solving a very famous interview question. Find peak element in the array, and this question is even asked in Google as well. So let's first understand the question better. So we have given an array of four elements, right? 5, 10, 20, and 15, and we have to find the peak element in the array. Peak element is the element which is basically greater than its neighbors. Okay, so neighbors, I mean that let's say we have an element 10, right? And neighbors of 10 are 5 and 20, which is element basically on the left of 10 and right of 10, which is 5 and 20. And neighbors of 20 are 10 and 15, which are again elements which are on the left of 20 and right of 20. Okay, now we will check the neighbors of leftmost and rightmost elements. So neighbor of 5 is only 10 because there is no element on the left of 5, and same goes for 15 also. There is no element on the right of 15, so neighbor of 15 is 20 only. Okay, now peak element is the element which is greater than its neighbor. Let's now check if 10 is peak element or not. So neighbors of 10 are 5 and 20. So we have to check if 10 is greater than both of its neighbors, right? So we'll check if 10 is greater than 5. Yes, true, right? But 10 is less than 20. So it's not greater than its both of neighbors. So 10 is not the peak element. Now let's now check for next pair, which is 10, 20, 15. We will be checking if 20 is the peak element. So we will compare 20 with 10. Yes, 20 is greater than 10, which is its left neighbor, and true, right? And now we will compare 20 with right element, which is 15. 20 is greater than 15, right? So 20 is our peak element, and 20 should be the answer. So now, what if there are more than one, what do you call, more than one peak elements? For example, if in this example we have given 25, right? Now 25 is greater than its neighbor 15, right? And 20 is also greater than its both of neighbors 10 and 15. So both are peak element 20 and 25. So we can return any element. Okay, so now let's jump to code, like how we'll be solving this. And like I highly recommend you to pause this video at this point and try to solve the question on your own, and then you can understand better. Okay, and one key thing and advice I want to give is like uh, first before writing the code, right? And just think like how you are solving that problem manually, and just you have to frame that manual steps into the code. Okay, now how I was solving manually was like I was comparing. So if you see, to check if 10 is my peak element or not, I was comparing 10 with 5 and 20, right? Now let's say if my, let me pick different color. Let's say my, I am checking for 10, and 10 is, let's say, my I. And now I'll compare 10 with my I plus 1, which is 20, and I will compare 10 with my I minus 1. So what I have to do is just a for loop, right? And we'll have to iterate all the by with for all the elements one by one. Yep, let me. So what we have to do is we'll start a loop. Let's say I1, and we'll go till array length and I plus plus. Now what I was doing manually was comparing, basically I was checking if I is greater than I plus 1 and I is greater than I minus 1, then I was considering that element as a peak element. So same thing we have to do here. So for array of I, we will be checking if if array of I is greater than I plus 1, and if array of I is greater than array of I minus 1, then that element is a peak element. But this is about so this is for all the element which are in between, which has basically both of its neighbors, right? I minus 1 and I plus 1. Now, these two cases, first and last one, we have to consider. These are special cases, right? We have to handle that explicitly. For example, if I is 0, I will compare only it with its right element, and if element is the last element, I will compare it with only the second last element. So let me show you the code quickly. Okay, so and one more thing, if let's say there is no peak element in the array, like there is no element basically which is greater than its neighbor, so in that case we have to return -1. Okay, now see, like I have given this array 1, 2, 3, and here is a function which is calculating the peak element. So let's see what it's doing. So if array of length equals to 1, if let's say array has only one element, right, then we will return that element. We will consider that element as a peak element and we'll return that. Okay, that's what it's doing. If array has only one element, just return that. And as I explained earlier, so if array has if first and basically first and last case we have to consider, we have to handle separately. So I am comparing array of 0 with array of 1 because this doesn't have any element on left, so I don't want this to enter into the below for loop. So I'm just comparing if array of 0 with array of element which is at first location. So if 5 is greater than 10, then I will not return, I'll continue. And that means that's not a peak element. If let's say here 45, right? So I'll just compare these two elements. 45 is greater than 10, which is the only neighbor. So I'll just return that. 45 is my peak element. Okay, and the next if condition is array of, here basically what I am doing is, what we have to do is, so for the last element, right, let's say I array have an element, so it's 0 based indexed, right? So I am comparing, I'm checking if array n minus 1 is greater than n minus 2, then that's the peak element. That's the only one, right? This is my n minus 1, this is my n minus 1, and this is my n minus 2. Here n is my array of length minus 1. I'm comparing with array of n minus 2. If that's greater than, then I'm returning this element, considering that element as peak element. And rest is the element which are in between, like 10, 20, 15, which has both of its neighbors. So we are like there is a for loop which basically starts from I1 and length minus 1. Okay, and so it basically compare the element with both of its neighbors I minus 1 and I plus 1, and checks if it's greater than both, it considers that element as a peak element. That's all. And now if you see, uh, if we talk about the complexity, right, so basically to calculate the peak element, it's basically touching each and every element and comparing, right? So then the complexity will be O(n) because it's at least touching each element of the array at least once, right? So that's the O(n) will be the time complexity. Now in my next video will be covering the optimized version of this using divide and conquer approach. Thank you for watching. Bye.